Hello everybody, it's Professor McDonald here on Monday, January 25th, and I am answering questions from my Lumen Ohm inbox as I do twice a week on Mondays and Thursdays. So any questions that you have from the guided learning assignments, this is how I answer those, and I do that only on Mondays and Thursdays. So please make sure to submit your questions before Monday or before Thursday so that you can get an answer to your questions before the due date of the upcoming assignment. So I only had a few questions. So let's see. The first one here says entering special answers. This was from the student tutorial. And the question is, how many numbers are there between 1 and 4? Well, between 1 and 4, there are an infinite number of possible values. You can have, obviously, 2 and 3 are between 1 and 4, but you could also have 1.5, 2.5, 2.25, 2.01, 2.000001, and so on. So the answer here is infinity, and if we read up here, it says in special cases, you may need to enter infinity, and so we use 00 for infinity. So we're going to go ahead and put that in, and that's it. And then you cannot divide anything with 0. It's just like if you had a cake and let's say there was a cake in an empty room and there was really nobody there to have any of it. There's no way to divide a cake into 0 pieces. And so just like with any quantity, it's the same situation. You cannot divide a quantity by nothing. So the answer here is does not exist. And as you can see up here, D and E. So that's it. Now let's move on to the next question. Let me just pause here for a moment. Annual high temperatures in a certain location have been tracked for several years. Let X represent the year and Y the temperature. This is question number 12 from GLA number 1. It says, based on the data shown below, calculate the correlation coefficient to 3 decimal places between X and Y. Use your calculator. All right, our calculator is Excel. So we're going to go ahead and copy the data and paste it into our spreadsheet. And to calculate the correlation coefficient, just get into a cell, press equals, and start typing in correlation. After a few letters, you'll see that this is recommended, Correl, C-O-R-R-E-L, and it returns the correlation coefficient between 2 data sets. Perfect, let's do that. Let's double click that, and then select array 1, which is all your X values, comma, then array 2 is all your Y values, and press enter. And there you have your correlation coefficient, which we can go ahead and enter for our answer here. Now it says to round to 3 decimal places, and so I'm going to do that. And that's that question finished. Here is another question from the student tutorial. Remember, this does not affect your grade, but I like to make sure you guys feel comfortable entering answers. So we're going to make a fraction, and then we're going to put in 8, and then use the power to go and put 17. Then use the arrow key to get down to ground level again and do minus 15. Then we'll go down to the bottom and type in the denominator 11. Next, we have 12y, and then you can click on the exponent box again. Or another thing that works just as well as this button is to just use the caret key, which is above your number 6 on your keyboard. And that was supposed to be a 3. Let's fix that. Okay, now ground level. Remember, to get down to ground level, you use the right arrow key plus 15x to the power of 2. All right, then we have the square root of 8 plus z. So I'm going to use my square root, then 8 plus z, and that's done. And finally, we're going to need a fraction again with a square root of 17 in the top, and in the bottom, t plus 8. All right, that's that question finished. Choose the most likely correlation value for the scatter plot. Okay, so the student commented that they still didn't understand how to calculate the correlation coefficient. You don't calculate it for this. You're just visually inspecting the scatter plot and guessing which one of these would be the best fit for it. Now, this is a very random scatter. It doesn't look like a linear pattern at all. I don't see any kind of line shape being formed by those dots. They're just kind of all over the place. So I'm looking for a correlation coefficient that is close to 0. Remember, correlation ranges from perfectly 1 or perfectly -1 and everything in between. And 0 means no linear correlation. So if you have a perfect straight line that is increasing from left to right, then you will have a value that is close to 1. And if you have a perfect or close to perfectly looking straight line, it'll be going downhill. That would have a -1 correlation. So we don't see any correlation really as far as a line pattern is concerned. That's why I'm going to choose the one that's closest to 0. And that's it. You don't have to do any calculating. You're just visually understanding what the correlation coefficient must have to be for that. All right, so we're going to go on to another. All right, so this question came up in my inbox again, and I answered this in my last Q&A session, and I also have it in the student Q&A section in Blackboard. So please don't forget to look at the student Q&A section where I often will post the YouTube Q&A playlist has recent answers that I've made, and also you can scroll down and see what other questions I've answered in the past via video for students. And question 15 is certainly a popular one, and in fact that is already here under the student Q&A section. So please go there and watch that video again. All right, so this one says 2 statistics students at UCLA conducted an energy efficiency survey of graduate student apartments. There were 7 university apartment buildings, and the students randomly selected 3 to be included in the study. In each building, they randomly chose 25 apartments. What is the largest group of students that the study results represent? Well, let's reread part of this. It says there were 7 university apartment buildings, and the students randomly selected 3 of those buildings to be included in the study. So we're selecting 3 buildings out of a total of 7 in the population. So this is the population, 7 university apartment buildings, right? All the students in those 7 university apartment buildings. And from that, we took a smaller sample of 3 of those buildings. So we're looking for the answer that is very specific to these 7 buildings. So as you can see, all UCLA graduate student apartments, no. All UCLA graduate student apartments in the group of 7 buildings, yes. All UCLA graduate student apartments in the 3 sampled buildings, no, that's the sample, that's not the population. And remember, when we're talking about a study representing someone, it's representing the entire population. So it would not be the actual sample. And the last option, all UCLA graduate student apartments that were sampled in 3 buildings. Again, no. Okay, so the only one that makes sense is this one right here. And that's the end of that question. All right, here we have question number 13 from lesson 2. It says the faculty senate at a large university wanted to know what proportion of the students thought foreign language classes should be offered for everyone. The statistics department offered to cooperate in conducting a survey, and a simple random sample of 500 students was selected from all the students enrolled in statistics classes. A survey form was sent by email to these 500 students. A, in this case, the population of interest is. Okay, so we have to read who they're interested in finding out information about. Let's read the top line again. The faculty senate at a large university wanted to know what proportion of, now here they mention the population, the students, okay? Which students? All the students at a large university, right? The students that are at their university, right? So that's what this is supposed to be representing. So all the students at the university is the correct choice. That would be the population, all of the members that are in that we're interested in. Okay, we want to know what their opinion is, all of them. Now, rather than going and trying to take a census of everybody's opinion in the entire university, they're going to do a sample. And it says in this case, the sampling frame was, all right, so in other words, where were they selecting the members that would just be in their sample? How were they doing it? Were they sampling from all the students in the college, or did they use some other method? So it says that, let's see, a simple random sample of 500 students was selected from where though? Because that's the sampling frame. From all the students enrolled in statistics classes. Okay, so that was the sampling frame. So let's go ahead and choose all the students enrolled in statistics classes. Now, if you are a member of the Faculty Senate and you're trying to figure out what the opinion is of the entire body of students, does it make sense to only sample from students who are enrolled in statistics classes when you're talking about their opinion of whether there should be more foreign language classes offered, right? Do you think that there's any kind of bias that could occur if you're only talking to students who are taking statistics? And so that's what the last part is. Which of the following is true about the study? Either the A, since the sample is random, it is representative of the population of interest. Now, certainly having a random sample is a good thing, and it did say it was a simple random sample, of 500 students, but it was only selected from all these statistics students. So just being simple random isn't necessarily enough for it to be representative of the entire population of interest, the entire population of all the students at the whole university. So let's choose the second one. Even though the sample is random, it is not representative of the population of interest. I have to go with that. Yeah, so let's see. Yep, all right. So that's how you answer that question, and we're moving on. All right, guys, so that was the last question in my inbox. So I'll be recording another one of these on Thursday, excuse me, a few days from now. And you do have an assignment due by midnight on Thursday, so make sure you submit questions by Wednesday. Therefore, that way I can actually answer them on Thursday in time for you to get an answer before your assignment is due. And I hope this helped. Please remember to also check here for answers to commonly asked questions, as well as clicking here to view any new questions that have been posted in my student Q&A playlist this semester. Hope everything's going great, and I'll see you in the next video.